Welcome to the ECOi commissioning training video. This video covers the commissioning guidelines and procedures for the VRF heat pump and heat recovery systems. Remember to always leak check the system with dry nitrogen. We recommend using the 3-stage leak check method. The first stage should be at 200 psi, for a minimum of 8 hours. The second stage should be at 300 psi, for a minimum of 8 hours. And on the third stage, you should use 450 psi of dry nitrogen, and it should hold for a minimum of 24 hours. This portion of an ECOi installation is the most critical. If you do not perform a thorough leak check at this time, it can become costly and very time-consuming to find a leak later on. Once you are sure that you do not have any leaks in the refrigerant lines, the system will need to be evacuated down to a minimum of 500 microns. A micron vacuum gauge should be used to ensure that you have an accurate measurement. The triple evacuation method is strongly recommended. If you have combined condensers, also evacuate the oil equalization line. Once you have achieved a vacuum of 500 microns or better, the next step is to calculate the additional amount of refrigerant needed to properly charge the system. During the installation process you should keep an accurate count of the total liquid line length. You do not need to include distribution joints and elbows in your total liquid line length. In this example, we have a total of 100 feet of half-inch, 100 feet of 3/8, and 100 feet of quarter-inch. Now you will need to multiply the total length of each line size by the multiplier. The multiplier for half-inch is 1.38 ounces per foot. So we multiply 100 times 1.38, which equals 138 ounces. For 3/8, we multiply 100 times 0.602. That equals 60.20 ounces. And for quarter-inch, multiply 100 times 0.279, and that equals 27.90 ounces per foot. Add up the three totals, and we end up with 226.10 ounces. Divide the total by 16 for a total of 14 pounds 1 ounce. That's the total amount of additional refrigerant that will need to be added for a proper charge. Here are the refrigerant charge multipliers. This table can be found in the installation and service manuals. This is the piping diagram. It has the piping sizes that are used during the installation. In this example there is an initial charge amount. This means that the condenser needs 113 ounces of refrigerant in addition to the amount calculated from the liquid line lengths. Do not use gauges to check the refrigerant charge. There are too many variables in a VRF system to correctly verify the charge using refrigerant gauges. The best method to ensure a proper charge for an ECOi system is to weigh in the refrigerant. Commissioning ECOi systems. Let's take a look at the U/LE Mini ECOi mainboard. LEDs 1 and 2 are used as the unit status indicator. If a system error is present, it will display the error code. The red dial labeled S004 sets the number of indoor units that are connected to the outdoor unit. The black dial labeled S002 is used to set the refrigerant circuit number. This allows a central controller or a servicer to differentiate between multiple ECOi systems in one location. The EEPROM chip is a non-volatile and removable configuration storage device. Indoor and outdoor unit information is written to and stored in this chip. The pins labeled A.ADD, CN51, are used to initiate the auto-address procedure. When the auto-address is in progress, the outdoor unit looks for all the indoor units connected to the SNet, and communicates with them. Once this procedure is completed, and correct, it is stored in the EEPROM chip. Let's take a closer look at the U/ME, and the U/MF, heat pump and heat recovery mainboard. LEDs 1 and 2 are used as the unit status indicator. These lights will blink alternately when the auto-address procedure is in progress. If a system error is present, it will also display the error code. The black dial labeled S002 is used to set the refrigerant circuit number. This allows a central controller or a servicer to differentiate between multiple ECOi systems in one location. The red dial labeled S004 sets the number of indoor units that are connected to this outdoor unit or units. When multiple condensers are combined together, S006 is set on the main unit. This tells the main PCB that there are 2 or 3 condensers combined. The other setting that needs to be configured when condensers are combined is S007. This sets the outdoor unit address, and it tells the unit to either be the main or sub. An outdoor unit address of 1 sets the unit as the main. The main unit always has terminals 1 and 2 connected to the indoor units. The pins labeled A.ADD, CN100 are used to initiate the auto address procedure. When the auto address is in progress, the outdoor unit looks for all the indoor units connected to the SNet, and communicates with them. Once this procedure is completed, and correct, it is stored in the EEPROM chip. Let's look at how the dip switches work with the rotary dials. In Figure 1, there are examples of the number of indoor unit settings. The factory setting of the dip switches is in the off position. In this configuration you can set up to 9 indoor units on the rotary dial. If you have 21 units, you would set dip switch number 2 to the on position and set the rotary dial to 1. If you had 40 indoor units, you would set dip switch number 1 and 3 to the on position and the rotary dial to 0. Figure 2 shows some examples of the refrigerant circuit address settings. Once again the factory default is both switches in the off position. This would allow you to select a refrigerant circuit address of 1 through 9. If you needed to set the refrigerant circuit to 21, you would set dip switch 2 to the on position, and the rotary dial would be set to 1. These details can be found in the installation manual. Now we have to set the number of outdoor units, and outdoor unit address. Figure number 1 shows the possible configurations available when combining 2 or 3 units. By default the factory sets the condenser to be a standalone unit. If you are combining 2 outdoor units for increased capacity, you will have to set the board on the main unit to recognize 2 condensers. When combining 3 outdoor units, the main board, on the main unit, will need to be configured to 3 outdoor units. This is accomplished by setting the dip switches 1 and 2 in the on position, and dip switch number 3 should be in the off position. Now we have to configure the outdoor unit address. The condensers come from the factory set as the main unit. In a combined configuration, the outdoor unit that is set as the main, has the U1 and U2 wired to the first air handler in the daisy chain. The condenser connected to the main via the 3 and 4 terminals will need to be set as a sub-unit. This is done by configuring the outdoor unit address on the board of the sub-unit. Dip switch number 2 should be in the on position, and the others should be set to off. This condenser has now been set as the first sub-unit. The third condenser will be configured as outdoor unit number 3. This is done by placing dip switches 1 and 2 to the on position. The third dip switch is set to off. In this example, the condenser on the left has been set as the main unit, because the control wiring is connected to the first indoor unit in the daisy chain. On the main unit, you must configure the refrigerant circuit number, total number of indoor units, the total number of outdoor units and the outdoor unit address. The only setting on the sub-unit, or units, that must be configured, is the outdoor unit address. It is also labeled S007. When you are configuring a condenser as a sub-unit, it is controlled by the main outdoor unit. Once you have configured all of the necessary settings on the main and sub-circuit boards, you are ready to auto-address the refrigerant circuit. Simply short the pins labeled A.ADD for 3 to 5 seconds. When the auto-address procedure has been initiated, LED 1 and 2 will begin to blink alternately. Once the LEDs begin blinking, you may release the short on the pins labeled A.ADD. Once LEDs 1 and 2 turn off, the refrigerant circuit has been completely addressed. Let's take a closer look at the auto address procedure and how the settings are applied to the refrigerant circuit. In this example, we have one refrigerant circuit. When refrigerant circuit number 1 has completed addressing, the condenser will assign the indoor unit number. Refrigerant circuit number 1 has been fully addressed. The first digit represents the refrigerant circuit number. This value was set when the refrigerant circuit number was configured on the main board on the main outdoor unit. The second digit is applied by the condenser board during the auto address procedure. The indoor unit number is randomly applied by the main board in the outdoor unit. When commissioning multiple refrigerant circuits, there is a certain order in which it should be performed. Let's start with refrigerant circuit number 1. Apply power to the condensers for a minimum of 5 hours. Apply power to all of the indoor units. Configure the main PCB settings. Auto-address the refrigerant circuit and perform a test run of the refrigerant circuit. If the test run has proven that the refrigerant circuit is operating properly, repeat the process until all of the circuits have been addressed and tested. Both refrigerant circuits have been addressed and are operating properly. Now the refrigerant circuits can be linked together via the U1 and U2 connections. We recommend making this connection at the outdoor unit. At this time, introduce the intelligent controller or the system controller to the SNET. You will also need to initiate the central control address setting in the device you have installed. If your job as a controls device such as a LANWorks adapter or a BMS controller, introduce it into the SNET last. When you have multiple refrigerant circuits linked together, it is necessary to adjust the communication signal to maintain the proper signal strength over the SNET. As shown in this example, one condenser of the 5 refrigerant circuits will need to be in the closed position. The remaining condensers should be placed into the open position. This also includes PACI units that may be present on the SNET. All ECOi boards have EEPROM chips on both the indoor and outdoor units. EEPROM chips are non-volatile and they store system information such as unit type, capacities, unit identification numbers and customized settings for your customer's needs or desires. The EEPROM chip can only be accessed with a CZ, RTC2, and the CZ, RE2C2 wired controllers. How to retrieve error codes and their meanings. There are 2 ways to retrieve error codes. You can either use LEDs 1 and 2, or by plugging in a CZ, RTC2, into the main board in the outdoor unit. If you choose to use the latter, you will need the maintenance controller wiring harness. The part number is 623-178-5082. Connect the wiring harness to the CZ, RTC2, and plug the harness into the female connector labeled RC, on the main board. How to read alarm codes using LED 1 and 2. If the unit has a P17 error code, LED 1 would blink 2 times, this means that the letter code of the error is a P, and LED 2 blinks 17 times, so we now know we have a P17 error code present. When you are commissioning an ECOi system, the most common error codes you may encounter are communication errors. These error codes begin with the letter E. Some of the probable causes of communication errors are as follows. The U1 and U2 control wiring is open, shorted or not properly daisy-chained. An indoor unit or units do not have power and cannot communicate with the outdoor unit. The outdoor unit does not have power, and they cannot communicate with the indoor unit. The rotary dials or the dip switches on the main PCB have not been set correctly, and does not match the number of indoor or outdoor units connected. A blown fuse on either the indoor or outdoor circuit board. An indoor or outdoor circuit board has been replaced and the EEPROM was not removed from the old board and transferred into the new board. Incoming voltages are lower or higher than 10% of the rated voltage. You can check your control wiring for a break or short by using a meter. Set your meter to the ohms scale, and measure the resistance at the U1 and U2 terminals. If your control wire has not been cut or grounded, you should read around 100 ohms at both the indoor and outdoor units. Another common error during the commissioning process is a PO5. This error will lock out the condenser as soon as power is applied. A PO5 error represents a reversed or missing phase. To correct this condition, switch any two phases of the high voltage entering the condenser. Be sure to verify that all three phases are present. Let's review the startup procedures. Summary for the refrigerant piping. Complete the third stage of the pressure test, with 450 psi of dry nitrogen, for a minimum of 24 hours. Evacuate the system to a minimum of 500 microns, and hold the vacuum for a minimum of 24 hours. Calculate and add the additional R410A refrigerant needed. Remember to always charge R410A in liquid form only. Open the outdoor unit service valves. Confirm that all of the refrigerant lines have been properly insulated. Summary for the control wiring. Verify all control wiring and wired controllers have been terminated properly. Verify that the high voltage wiring to both indoor and outdoor units have been properly completed. Confirm that condensate power and safeties have been properly connected. Energize the high voltage supply to the outdoor units. Allow the crankcase heaters to operate for a minimum of 5 hours before the condenser's first run. Make sure all of the air handlers and condensers have had the power applied before initiating the auto-address procedure. Summary for the auto-addressing procedure and test run. Set the rotary and dip switches to the proper system configuration. Apply power to all of the indoor units to be addressed. Initiate the auto-addressing sequence by shorting the A.ADD pins on the main PCB in the outdoor unit. Correct any alarms if present. Once the system has addressed, perform a test run and verify proper operation. This concludes the ECOi heat pump and heat recovery commissioning video.